Hello and welcome to this Mobile World Live webinar. I am Michael Carroll, a senior editor at the publication, and I'm delighted to be your moderator for today's event. During the event, we're going to explore how open networking is being employed to unlock the full potential of 5G technology. Momentum around open and virtualized networking is gathering pace, fueled by big-name deployments by Rakuten Mobile and a growing number of industry groups, including the Open RAN Alliance and Telecom Infra Project. Research group Dell'Oro Group has predicted global spending on Open RAN equipment alone will total $5 billion over the next 5 years. Open RAN is being tipped as a key enabler of 5G deployments globally, enabling a wide range of companies to participate with specific research initiatives, such as the opening of an open networking laboratory by Taiwan's government last month, designed to help vendors compete on a worldwide stage. Here is a brief explanation from Chi-Cheng Yang, Deputy Director General of the Industrial Development Bureau at the Ministry of Economic Affairs.
Ladies and gentlemen, welcome. On behalf of IDB, I welcome you all to 2020 World Telecom Conference 5G Talk. Taiwan's ICT industry has always been a great partner to operators around the globe. With the 5G commercial launch, 5G supply chain has become an important engine for economic growth. In particular, open networking becomes a key topic, especially to Taiwan's ICT industry. To share one example, edge computing servers and 5G small cells by Taiwan's ICT vendors can be found in the case of Rakuten's 5G network. Given our expertise and agility in hardware manufacturing, Taiwan's ICT supply chain is in the best position to help contribute to the global 5G ecosystem. To help Taiwan's ICT industry catch up with the 5G wave, IDB announced the launch of Taiwan's very first 5G Open Networking Lab in August 2020. In this lab, we bring together global players like Cisco Systems and Taiwan's ICT vendors, such as Compal Electronics, Lion Taiwan Technology, Telecom, Ufi Space, and SI like Huacom Systems. In this lab, our vendors can do integration and IoT test based on the open networking architecture, such as ORAN, OTIP, Telecom Infra Project. Through this lab, we hope to speed up 5G product development within Taiwan's ICT supply chain and to create more business opportunities for our industry. In today's 5G talk, we are pleased to invite BT, Chunghwa Telecom, Ufi Space, and ARM to join us and to share their insights on how we can unlock the 5G potential of open networking. With that, I wish you all a very fruitful discussion. Thank you.
Theory and laboratory trials are one thing, but how does it all work in practice? Here to discuss and offer real-world insights are Richard Mackenzie, Principal Researcher at BT, Zhu Yuan Tang, Researcher at Chunghwa Telecom Laboratories, Ray Chang, R&D Director at Ufi Space, and Sammy Huang, Principal FAE at ARM Taiwan. Everybody, hello.
Hi.
Hello.
Now, while our experts are presenting, I'd like to encourage our audience to interact by posting comments and questions. We will have time at the end of the presentations to address some of those questions. So to get involved, just post those questions in the box underneath the slides and we will try to answer it. But without further ado, I will hand over to Richard.
Hi, everybody. My name's Richard Mackenzie and I work for British Telecom in the Wireless Research Department. And today I'd like to talk about RAN disaggregation and how that's going to enable us to achieve all of the services that we want to get out of 5G. Next slide, please. So a very gentle introduction, and I'm sure that this diagram isn't unfamiliar to anybody, but it's very good to start with the basics to make sure we're all on the same page for the following discussions. So one of the main components of disaggregation is the fact that we're breaking the base station. So in this example, a G node B, we're breaking that base station into several components. And the typical terminology we use is the radio unit, the RU, the distributed unit, the DU, and the central unit, the CU. One of the fixed rules is that the RU has to remain at cell sites. After that, we've got a lot of flexibility. The DU and the CU can also be at cell sites. They can be centralized to different extents. And what we need to do is ensure that wherever we place them, it enables us to achieve the 5G service that we want. And we have to consider the transport requirements. So as we separate these different components in the RAN, we may be making the transport requirements tougher or easier. In addition to that, there's another form of disaggregation, and that is the decoupling of the hardware from the software. So while hardware is required to run all of these different components in the base station, it's now possible that we can run all of them as software functions on a common compute platform. So that's what I'd like to discuss over the following few slides. Next slide, please. So one of the key industry groups that's enabling us to have this open disaggregated network is the O-RAN Alliance. So one of the key things they do is they are a standards body, and they are standardizing the interfaces that allow us to disaggregate the RAN. So in this diagram, you'll see the red boxes towards the bottom. That's the RU and the DU, and they're separated by the open fronthaul interface. Then we'll see the yellow boxes. That's the CU, and that's actually disaggregated itself into control plane and user plane elements. So that gives us further flexibility in how we move these components around the network in order to achieve the best performance. There's another new entity that is a key part of the RAN, and that's the RIC, so the RAN Intelligent Controller. So here we see that's the blue box and the purple box. And what the RIC enables us to do is control all of the different components of the RAN, whether they come from different vendors, wherever they're placed in the network. The RIC enables us to coordinate all of these elements and ensure that we get the best coordination, the best performance, and provide the full range of 5G services that we want. The reason that RIC is broken into two elements is simply the timescales that it works over. So the blue near real-time RIC is doing optimizations on the order of milliseconds up to a second. So that will make decisions on handover, load balancing, things like that. And then the non-real-time RIC, that's making optimizations and analysis on the timescale of seconds or more. So that could be minutes, hours, even days. So that's where we see the big opportunity for data analytics and machine learning. And then if we look at the bottom box, that's what they call the O-Cloud. That's just saying that there is a common platform that we can run all of these elements on. And again, that's just reflecting the other key element of the hardware-software decoupling. Next slide, please. So Open RAN, that's the term that I think most of us use now. And what exactly is Open RAN? Well, it's pretty much the same as what we described in the previous two slides, but its origin is from the Telecom Infra Project, or TIP, as many people refer to it. And this is an example of their reference architecture. So it has exactly the same components as we've discussed before. So the base station is broken into an RU, a DU, and a CU, and we have the hardware-software decoupling. So what we really want to do here, and what TIP are trying to achieve, is an ecosystem to enable this. So one of the key elements that I haven't mentioned so far is the fact that these different elements in the network can come from different vendors. And it's possible to change one of those vendors at a different time. And in the case of software, we could be running different software elements, moving them around the network during the live provision of a service. So there's a lot of flexibility that we expect to achieve, and we expect to do it with a very diverse ecosystem of operators, vendors, and innovators. So what I'd like to focus on here is just a few mentions of where BT have been very active. So we've been co-chairing the vRAN fronthaul project, and that was looking at achieving an Open RAN system where the fronthaul interface doesn't require fiber. So that enables an operator to deploy this sort of architecture without having to upgrade their transport network first. So that's a real improvement to the business case. And what we managed to demonstrate there was several different implementations of multi-vendor solutions. So the RU and the DU and CU came from different vendors, and all of them worked over non-ideal fronthaul. So that project has now graduated, and we've turned our attentions to another project which we're just starting up, which is called RIA. So that is RAN Intelligence and Automation. And what that's looking to do is use machine learning and artificial intelligence to enable all of the diverse range of 5G use cases that we want to achieve in this Open RAN ecosystem. And in particular, we're focusing on how we achieve those optimizations using the RIC. So if we now move on to the next slide, this is the one I'd like to finish on, and I think it's a good one for generating lots of questions for our Q&A session. So this is a typical example of what a 5G disaggregated net RAN architecture would look like. And essentially on the left-hand side, we have lots of cell sites, and those cell sites will all connect to a core network via a series of aggregation nodes. And they're usually in a hierarchy, and in this example, we've used tier 1, 2, and 3. And for every tier 3 site, you would typically have 10 tier 2 sites and about 100 tier 1 sites, and there'd be about 1,000 cell sites on the end of that. So that's how the dimensioning tends to work. And I've just colored this all in blue because blue just represents the potential for compute. So we could put a common compute platform at all of these locations, and we can therefore run all or some of the RAN functions in those locations. And this is where we get all of the flexibility from an Open RAN design. We can make a decision of whether we want to centralize the RAN as much as possible, and so that could help us run the network more cheaply. It could give us better coordination because we now have all cell sites coordinating to a single point. We can get pooling gains. We can get improved mobility because essentially you're not handing over as you move between cell sites. And we can do better load balancing. So there's a lot of benefits to doing centralization, but there's also some disadvantages. One of them is the transport. So the transport typically becomes harder to provide and more expensive. On top of that, we also have some other challenges simply with scalability. So as we think about what services we want to provide and how many customers we want to provide those services for, we may have a different opinion on where we want the different RAN functions to be placed. So as Open RAN ecosystems evolve, we may see more clearly the exact design of a RAN architecture. But at the moment, it is this open design with lots of decisions to be made and lots of room for innovation and competition. So I think this is exactly what Open RAN is trying to achieve, and I think this is a very exciting year for seeing Open RAN mature into commercial solutions around the globe. So I'll leave it there, and hopefully that's generated a lot of questions from the audience, and we can discuss those during the Q&A session.
Thank you, Richard. We now hear from Zhuan Tang from Chunghwa.
Hello, everyone. My name is Zhuan Tang. I work for Chunghwa Telecom in Taiwan, and I'm expertise in RAN access network. Now, today I would like to talk about the way toward open RAN, and not talking about how to go there, but I will share what Chunghwa Telecom is doing to go to open RAN. Okay, please, next slide. And let me introduce the mobile market status in Taiwan. And Taiwan's total land area is only 3600 square kilometers, and the population is about 23 million. However, Taiwan's mobile market is highly competitive. Currently, there are 5 operators in Taiwan. In contrast, most other countries only have 3 or 4 mobile operators, such as Japan, Korea, China, and the US. And considering the market size, Taiwan is indeed a strongly competitive market. In such an environment, Chunghwa Telecom is still the leading operator, owns the largest market share, and according to Taiwan National Communication Committee statistics, Chunghwa Telecom owns 38% market share by revenue. Okay, please, next slide. And CHT is the leading operator to launch 5G service first in Taiwan, and we plan to acquire more than 1 million 5G users in the first years, and hopefully we can migrate existing 4G users to 5G in 4 years, and will display 400 base stations in first year, covering 22 counties, main business districts, science park, train station, and nearly 50 colleges. And we will invest 27 billion to deploy 10,000 base stations in 3 years. And initial 5G applications include AR, VR applications, 4G video, lossless audio streaming, and 4G gaming. And more to 5G TOB applications will be available later. Okay, please, next slide. And we not only consider our network currently, and we need sustainably development. So we also consider the evolution of 5G for the future. And there are several trends, such as to make this network cost lower, and we need to use some white box hardware, and there are also network codification and softwareizations that make we can operate our network more smoothly. And there are many open source community and the standard is working for this, and Chunghwa Telecom also attend this organization and become a member of them. And not in addition, the operational intelligence and the automation is also very important. We know 4G network, even the 6G will be more and more complex, and we need our network become zero touch and automatically operate. We think this is very important trend for the future network, and because we can see the operation and the information technology and the communication technology must convergence. In such case, we can have we can serve our customers not only for the general customer, but also for the industry, for many verticals. And we think this is the business opportunity for operators for the future. Okay, Please, next slide. And what we are doing now to move forward to the Open RAN, and this is the evolution trend for 5G. We think it's a very, very long way to go there. And now we attend the Open Alliance and join their meeting and discuss with members about to promote the spec and its progress. And we also attend our domestic organization, that is a 5G Alliance, and we take part in one of the special interest group as the leader, and in Taiwan we plan this December this year. There is IEEE GlobalCon 2020 will be held in Taiwan, and we will show up our recent results. We collaborate with Taiwan and the international companies to show a demo which is demonstrate the openness and intelligence of open O-RAN, and and we are doing and we are preparing for that. To do this, the next step is we want to make sure this component, when they integrate into one network, they can work well to provide services from a vertical. And for the future, we will do POCs and field trials to make sure these networks can be commercially ready. Okay, I think the next slides. Okay, so I think this is my presentation, and I thank you for all.
And next, we have Ray from Ufi Space.
Hello, everyone. Today, this is Ray from Ufi Space. I'm the technology director. So today, I'm going to talk about how white box platform can create more flexibility and more innovative 5G network solutions. Next slide, please. So what is white box platform? Traditional proprietary hardware has all of its components sourced by a single vendor. A white box platform disaggregates hardware and software into separate components integrated with open interfaces. For our telecom customers, they will see benefits such as more choices, more innovative solutions, and more flexibility since they are no longer vendor locked. For our software partners, we also strive to create a more welcoming open networking environment. At Ufi Space, our software integration team also provides our experience and development packages to reduce development time, cost, and other barriers that software vendors might face when working with white box. Let's take a look at how we do that. Next page, please. From our experience engaging with customers, the disaggregated cell site gateway is what's most considered to be an entry point to open networking. With DCSG, customers can start small and realize the benefits of open networking before making major investments. There's also minimal interruption to service while enabling the implementation of 5G service. We have got a lot of experience working with node vendors, system integrators, and telecom customers so we can provide the necessary support needed to reduce the time and effort for implementing DCSG projects or developing solutions with software vendors on our white box platform. Next page, please. In our effort to foster open development, our DCSG has been contributed to both OCP and TIP. Our development support team also provides detailed BSP and offer our experience with software integration to help our partners bring their solutions to market faster. Next page, please. Next, we have our distributed disaggregated chassis, which is our white box platform for switching and routing in the core and edge network. Traditional chassis vendors develop their own software, which means that the core and edge network was very close. There were no opportunities for third-party solutions development. With the DDC, we are presenting our open networking benefits to customers such as a pay-as-you-go capacity upgrading model, more scalability and flexibility in their networking, and fostering more innovation and future-proofing their network. Additionally, we are providing value for our software partners by distributing hardware components into disaggregated white box to make it easier to develop for. We are also creating a platform for multiple applications within the core and edge networks using open networking solutions. Next page, please. Here you will see the building block for our DDC, the 100G white box line card and 400G white box line card, as well as the fabric element, which can form the scalability from 4T up to 192T capacity. Of course, our DDC has also been contributed to OCP and TIP. Our DDC has already been deployed into the core and edge networks of major telecom around the world. Additionally, we are working with several software vendors to develop even more applications with the same hardware platform, such as DCI, peering, firewall, traffic offloading, and broadband network gateway. Next page, please. Moving on to the RAN. This is the next puzzle of open networking. As we move from DRAN to CRAN and now towards ORAN, we can see how the need for the adequate front-haul gateway is needed, especially to meet the various application scenarios in the RAN when combining CPRI and eCPRI from the RU to DU-CU all the way to the separate 4G, 5G core. There have been many activities in the RAN, especially with ORAN. They recently released the specification for Open RAN. The front haul will be a major part of the Open RAN architecture. It will feature very precise timing and faster protocol conversion, as well as needing to be compatible with multiple vendors. We are also doing our part to make the transition to ORAN smoother. We have developed our own timing module and FPGA solutions, which include the ROE and low-fi functionality. All of this to provide real value for our customers and reduce the development time and cost for software application developers. Next page, please. Our goal at Ufi Space is to enable more efficiency within the open networking ecosystem by providing value and benefits for our customers, as well as providing a platform for application developers to create more innovative solutions. To do so, our white box platform fuse silicon systems, software, and system integrators together to accelerate time to market, reduce CapEx and OpEx, and open up the system for more development to happen. Next page. Thanks for listening, and this concludes our presentation. So if there's any questions, feel free to send us a mail or visit our website. Thank you.
And now, Sammy Huang.
Hi, everyone. I'm Sammy, FA from Taiwan. I'm mainly focused on high-performance solution and infrastructure application technology. It's my honor to be invited and join the webinar. As we know, 5G is transforming the whole infrastructure. Today, I would like to share my insight of infrastructure for now and future. Okay, next page. With 5G eras coming, it brings a whole new fully connected world, well beyond traditional connectivity. The performance improvement in bandwidth, low latencies, and number of connections with 5G technologies open the gate to a broad set of applications, such like immersive experience, smart city, healthcare, industrial IoT, autonomous transport, and so many that we even haven't thought yet. From N to H until cloud, the massive amount of data is revolutionizing the whole infrastructure. Today and before, faster general-purpose compute used to be good enough for all workloads. But now, there's a trend towards increasing so-called heterogeneity. As you know, it began with machine learning training on GPUs, and lately with the addition of tensor processing units. The offload of network, storage, security, machine learning bring out edge compute for data filtering and faster reacting. With heterogeneity, it can provide low power and low cost compute resource, which will be a big win for data center hyperscalers and telco companies, telco operators. Just like we see, the open platform solution is reconstructing RU, CU, DU in 5G O-RAN. Okay, next page. Since we launched on Neoverse platform with N1 and E1 CPU, we have been making incredible progress in the infrastructure. With working closely with our partners, we brought more heterogeneity and diversity to the market, and also bring more flexibility for different infrastructure applications, including server hyperscaler, SmartNIC for network, storage, and different accelerators. With our Neoverse platform, it provides the best efficient solution for the infrastructure market. We're delivering over 40% price performance advantage and 3 times number of virtual machines and more core density over different competing alternatives. It's definitely helped operators to cut operation expenses over the lifetime of their equipment. Today, ARM is ubiquitous in infrastructure market. Besides the second generation of ARM-based SoC AWS Graviton2 in Amazon data center, another exciting news is the world's fastest supercomputer, Fugaku, is powered by ARM architecture. That's really fantastic, right? Okay, next page, please. When talking about open platform solution, it is important to put real-world use cases to do verification and testing, side by side with telco company. Recently, we have an end-to-end open platform demonstration of 5G network. Running entirely on the hardware powered by Marvell's ARM-based processors. It's a complete O-RAN defined radio access network from 5G standalone core, centralized unit, distributed unit, to radio unit, and companion with different software stacks solutions, including Docker containers, Ultron, and Arraycom. Okay, next page. To broadly deploy 5G, software ecosystem is another critical factor. We collaborate with a broad ecosystem of developers and makes significant contributions in more than 100 open source initiatives, including CI/CD tool chain, different operation systems like Ubuntu, CentOS, virtual machines, containers, end-to-end security and networking software stacks. ARM is already a key player in telco-centric organizations such as Telecom Infra Project, DPDK, Open Platform for NFV, and Linux Foundation's Acrano project. Okay, next page. ARM has been at the forefront of enabling generations of cellular technology. With over 70% of the world's population now is using ARM technology daily. The ARM ecosystem plays a huge role in enabling 5G from endpoint all the way to the cloud. We have worked with the ecosystem for more than 25 years to become the leading CPU architecture of choice for base stations deployment around the world. We will continue our commitment with working closely with our partners and ecosystem, including silicon, hardware, and software, to deliver the best heterogeneous IPs and broaden the ecosystem with providing the acceptable total cost of ownership solution. I believe it's a whole new chapter and will bring a lot of new opportunities to everyone, also to Taiwan industry. Especially, we have very strong OEM and ODM partners in Taiwan, and also infrastructure supply chain, like WeWin, Gigabyte, and Pegatron. We are very excited and looking forward the next big steps in this journey to 5G. So let's embracing the beauty of 5G together. Okay, next page. Okay, that's my presentation. And thank you for your time and listening, and also join this webinar. We can have more Q&A later today. See you.
Well, thank you all for those real-world examples regarding the potential of open networking. We'll now turn things over to your questions and comments. Thank you for all of those already submitted, but don't worry if you've not yet placed a question, as there is still time. Just use the box underneath the slide presentation, and we will do our best to cover it during the session. So, folks, we do have quite a few questions. First, it seems to be probably Dr. Tang and Ray look suitable. The question is, what value does the recently announced 5G Open Network Laboratory in Taiwan bring to your companies?
Yes, I just mentioned that we will have a demo in December for IEEE Global Demo 2020. And now we are preparing for this demo. And for the first, the base station vendors and the core networkers have to do IODT. And they are doing this in 5G lab. So they after doing this, within we can make sure this network can work and can be commercially ready to some degree. So I think the lab is very important for us because this is the first step to make open RAN practical. Yeah. Okay, thank you.
Thank you. And Ray, would you like to chip in?
Yes. So I think based on our opinion, we see that what we can provide is an open platform. So with this hardware over open platform, we can invite lots of different node partners to join together and then to use the real demonstration and to contribute all the open community in Taiwan, especially that recently there's the open RAN and in Taiwan, Taoyuan. So there's lab that we are going to set up it and to have lots of interoperability tests and welcome all the local telecom service providers to join, and then to create more options, more solutions, and create more innovative platforms for different applications.
Thank you. Next question, Richard and Dr. Tang probably suitable. The question is, open networks and open RAN now are hot topics for 5G and new generation communication systems. They bring architectures and network elements, new ones. How will you adopt those into your networks and businesses, and are there any challenges?
Yeah, thank you for your question. We think by now it's too far to talk about commercial, but we join domestic and international open RAN and open networking organization, such as the 5G Alliance in Taiwan and the ORAN, and I think this is well famous. And the second, we also done several IODT and testing and lab testing to with our with several vendors, and after this we will do some field testing and integrated with our company's service. So we think this is a step-by-step progress, and will not be very fast or soon be commercial. Okay, and this is the first answer. And the second is, we think the open RAN, the virtualization RAN, has very much impact for our company. For example, the commission and operation and maintenance will change. And so we do this lab testing and the POC and make to figure out the issue. We should change our operation process. That I think this is very big change for operator. Yes.
And Richard, do you care to weigh in, also operator perspective?
Yeah, I think the most exciting new component in this architecture is the RIC, the RAN Intelligent Controller. That's going to enable us to build these networks that are truly multi-vendor and truly disaggregated. It's going to enable the operators to more clearly specify what functionality they want for every service that they want to provide over this network. So as 5G services become wider in demand, so rather than just being enhanced mobile broadband as we have now, as we start offering low latency services, high reliability services, even higher throughput services, we need to be able to reconfigure the network based on the user demands, and the RIC is the real way that we can do that. That's going to mature over time, absolutely, and the standards are just about getting in place now for those interfaces for the RIC. One of the early deployment scenarios we see for this, for Open RAN in general, is neutral host deployments, because that enables operators to share infrastructure, and because of the logical isolation that the software can provide, we can get most of the benefits of sharing, so the cost savings, without all of the restrictions that usually come with network sharing. So I think that's where we're going to see a lot of innovation and a lot of commercialization in the short term, but in the longer term, that RIC is going to be the enabler for all of these use cases.
Thank you both. Sammy, we have a question which is pertinent to yourself. 5G drives transformation in telecom, networking and IT. So what are the major reasons you think, or the major things that you think telecom operators should consider when they're building an open platform?
Okay. So as the number of devices increases, and new technologies such like AI, machine learning, AK video, it leads to higher workload and densities, and more performance and more power efficiency. So low TCO, total cost of ownership, are essential for fluid business operations. So with open platform, it provides performance and power efficiency for different workloads with best fit solution, which could help operators to lower their TCO in different applications. So I think open platform definitely will help telecom and deploy 5G system.
Thank you. Richard, back to you. What is it about 5G that is opening the door to opportunities for Taiwanese vendors compared with, say, 3G or 4G?
Well, I think it's not necessarily 5G, it's Open RAN. And Open RAN at the moment is focusing on 5G, but certainly we want to see Open RAN solutions that can provide the legacy radio technologies as well. But by doing this open architecture, we're creating a new ecosystem so that a company that has specialist skills can provide their solution for part of the end-to-end system rather than having to buy a full end-to-end system from a single vendor. So particularly, Taiwan's got lots of good examples of companies that could be disruptors that gain a much larger share of the market as we start to deploy Open RAN globally. But it's not just a Taiwan thing, and it's an opportunity. There may be new companies that are not yet established that have a good idea, a new innovative idea, and they could become commercially ready very quickly thanks to Open RAN.
Thank you. And Ray, very quickly, what opportunities do you see for Taiwanese companies to sort of benefit the global open network community, such as the Telecom Infra Project and others?
Yes. So, Taiwan company, we do have lots of company we can do OEM, ODM, but turn to the market trend that white box open platform. So all of these suppliers, we can do very good hardware platform for different node partners, use different applications, and then for different telco customers to select what they like from different hardware, different software, and enable different applications from RAN, SS, metro, up to edge and core. So this is actually create lots of opportunity, lots of innovative, and lots of flexibility for global telco suppliers.
Thank you, Ray. And I'm afraid that seems like we have to wrap up at that point. So thank you all for the very interesting insights and for answering all of the questions, and also to our audience for all of your questions and interaction. A replay of the presentation will be available shortly, so if you missed any of the content, you'll be able to catch up. And of course, you can always contact all of our guests through their company websites. Thank you once again to all of our speakers and to our audience for taking part, and goodbye.